Oh, all right. Welcome, Metal Fab students. We've gone over a ton of safety stuff here the last couple of weeks, and I'm still going to touch on some safety stuff with welding as we go through it. But today I thought I would focus more on welding theory. So I brought some stuff into the classroom here today, and I want to talk about the actual theory behind welding with electricity. First of all, you need an electrical circuit. So in this case, we have our two parts of our circuit. Now, just to make sure that we all remember everything about electrical circuits, just like a battery has two parts, you need in and an out to make a circuit, or if you're talking about an electrical cord, we need two parts to make a circuit. We need a connection between those two. So with welding, we have our two parts. We have what's called our electrode holder. Some people also call this a stinger, and our ground clamp. And really what we're going to do is we're going to put the parts that we're going to weld in between these two things. So, for instance, if I was going to weld on this plate of metal, I would have to connect my ground clamp to the plate, and then I would use my electrode holder to hold our electrode. Now, these are our electrodes right here, and these are called rods, and I'll talk about those in more detail in a little bit. But our electrode holder holds our electrode, and then the idea is that we touch the metal plate, which is a conductor connected to the ground, to create an electrical circuit. Now, just an electrical circuit alone isn't enough to create enough heat, the amount of heat that we want. Now, all of you did spot welding in the shop. Now, with spot welding, really what we were doing was something similar to this. We were using two pieces of, an electrical connection between 2 points to create current between those 2 points that create heat that melted the pieces together. Well, here we're going to use electricity to create heat, but instead of just using the resistance of it, we're going to use an electrical arc. So that means that we can't just have it touching, we have to have it removed from the part a little bit. And we're going to be ionizing the air, creating an electrical arc. All of you have seen this with lightning or with a spark plug. It's just a blue electrical arc that travels through the air. That arc is thousands of degrees in heat. And we're going to use the heat of that arc to actually fuse metal together. The rod itself will be part of the weld. We'll actually consume the rod as we go. But really it's the heat of the arc that does the work. As far as, the actual getting shocked by this thing, it is possible to get a shock from it. The shock will be minimal because really what the welder does is it takes the voltage down. The welder itself is actually a transformer. It lowers the voltage and raises the amperage. What that means is that it makes it less likely that you'll get shocked. The only way you get shocked by this thing is if you were to touch the very tip here with your finger or stick your finger inside here to get shocked. That's really the only way that you're going to get shocked by this thing. If you're in a dry environment. If you're in a wet environment, like wet dewy grass, which you shouldn't weld in, pools of water, snow, rain, which you shouldn't weld in because it's dangerous, that's when you can get shocks that can kill. As long as you're in a dry environment, you won't get shocked as long as you don't do the things that I just mentioned. Especially if you're wearing gloves, you're not going to get shocked. So I don't want anyone to be scared of this, but you should respect it. All right. Let's talk a little bit more about the rods themselves. So, Dina, I don't know if you can get in here and show these rods here. The rods come in different diameters, number one. So the diameter of the rod, the larger the diameter of the rod, the thicker the metal that it welds best with. You can weld a 1/2-inch piece of steel with this rod, but you're not going to get really good penetration. That means you're not going to melt down, very deep into the metal with this skinny rod. This would be a 3/32 diameter rod right here. These are 1/8 inch diameter rods. Rods go up to a 1/4 of an inch, and there's some in between. And generally speaking, the rod that you're welding with should be roughly the thickness of the metal that you're welding for the best results. But oftentimes that's not the case. You'll have the wrong rod for the wrong steel, and you have to be able to figure out how to make it work to make it work the best. So the rods themselves are coated with, we have a metal rod going down the middle here, and you can see it's uninsulated on the end where it's going to go into the stinger. The rods themselves are coated with flux, and all of you remember that name, flux. In this case, the flux is used to shield the weld as you're welding. The puddle of molten metal that's created by this will want to attract oxygen to it, and if oxygen gets into that puddle, it's going to create a really porous weld. The weld's going to be crystalline. It's not going to have a lot of strength. And so while that molten puddle is cooling, we want to be able to cover it up with something. Well, in this case, as this flux melts away, it creates a smoky cloud over the molten puddle that protects it from the oxygen in the atmosphere. The numbers on the rods themselves, I don't know if you can catch that, Dina. Like this rod right here is a 6013. This rod right here would be like a 6011. I think I have another one in here too. This one's kind of hard to read. Oh, there it is. This one would be like a 7018. All of these numbers have meaning. The two most common that you'll come across are 6011 and 6013. Basically, what this means is, first of all, the 60 means 60,000 PSI, and if you remember from our talks earlier, that's pounds per square inch of tensile strength. Okay, and so tensile strength would be like if I literally tried to pull this plate of steel apart. If someone was on the other end, it would take 60,000 pounds of force to break the weld that I would create with this rod. Okay, the one right here, the one means position. Okay, and so when we're talking about welding positions, well, gravity is definitely going to have an effect on the way that the molten puddle reacts and the way that the flux reacts too. So if I were to weld like this would be considered a flat position. Welding up and down like this, that would be considered a vertical position. There's also horizontal position welding, and there's also overhead welding. Okay. Luckily for us, one just happens to mean all positions, so we can weld in all of those positions. By the way, the positions that we're going to focus on in this class is just going to be flat welding. It's the easiest ones to do, and before you can do any other ones, you need to master flat welding. So that's what we're going to focus on in here. The 3 over here is the flux type. And so, like I was talking about earlier, I was showing you those different rods. We had the 6013 and the 6011. A 6013 rod will put out a different flux type than a 6011 rod. Generally speaking, a 6013 rod is used on brand new clean steel. It does a great job. And a 6011 rod is a general purpose rod. A lot of people use that one for repairs. I'll show you the difference here quickly, and then we'll be done with our video. So, and I'm just trying not to get this flux to fall off. This weld right here was done with a 6013 rod. You can see when I started, the whole thing was coated with this nice, with this slag, it's called, this covering to protect the weld as it cooled. To get it off, I'm just going to hit it with this chipping hammer to get that off. This is a 6013 rod, puts out a really nice weld. A 6011 rod, that one puts out a little bit different coating. It's going to be a little bit more difficult to get that one off. It still produces a very nice weld, but the slag on it doesn't quite react the same way. And you can see it's much more difficult to get off. That's just one of the differences that there could be between the two rods. Okay, that's it for today's lecture. Tomorrow we'll go into the actual process of what I want you to do.